Welcome back to another exam walkthrough. We're going to be doing some questions on oscillations. This is going to be from 2024 October, Unit 5, question 19. So you can pause the video, read the question, and then attempt the question yourself. And if you want to see the mark scheme and the examiner report, you can go to the end of the video. And without further ado, let's start. So in the first part, they're asking you to show the stiffness of the spring to be about 45 Newton per meter. So we know Hooke's law, F is equals to K change in X, and we know that the force here is going to be equals to the weight, mg. So we can say mg is equals to K change in X, and then we can do mg divided by change in X is equals to K. So we're going to plug in the values and then we're going to get the value of K. So you're going to get the answer as 45.3 Newton per meter. And that's going to be approximately 45 Newton per meter. So that's going to be your answer. So in the next part, I want you to pause the video again, read the question, and I'm going to answer it. So the next part, they ask you to calculate the frequency of the oscillation of the bag. So here we can use time period is equals to 2 pi square root m over k. Now we know the value of k, we found that out to be 45.34 in the previous part. But here the mass we do not know. It's not going to be 550 grams anymore. It's going to be the mass of the animal, but we don't know the mass of the animal. So what we can do here is we can again use Hooke's law. We can say F is equals to K change in X, and then we can do mg is equals to K change in X, and we need to find the value of m. So the value of the mass is going to be 0.268 kg. And now we can plug it in the original formula. T is equals to 2 pi square root 0.268 divided by 45.34. And you're going to get the answer as 0.483 seconds. And then we know frequency is equals to 1 by T. So 1 over 0.483 is going to give me the answer as 2.07 Hertz. So we're going to write here 2.07 Hertz as the answer to the question. And then we have the final part, which says the mass of one animal was being determined. The amplitude of the oscillation of the bag was observed to increase to a large value. So this is going to refer to resonance. Resonance, okay? This is when the natural frequency is equal to the driving frequency. So here the natural frequency of the spring balance is equal to the driving frequency of the animal. The next mark you're going to get is going to be for writing that resonance occurs, or for writing that there is going to be maximum transfer of energy to the bag. And remember to identify carefully the driving frequency, who's causing it, and who is being forced into oscillation. That thing will have the natural frequency at resonance. So it's important you identify this as well. You apply this in context, okay? Because there is in many mark schemes a mark for applying this in the context, okay? So that's going to be all for this video. Now I'll show you the mark scheme and the